All right, so now we're looking at 2.4, and I'm going to go through some of the homework questions for it and kind of answer questions and work through some of them. Once again, I won't work through all of them. I'll give you a general overview of some of the problems and how you're going to look at them. With 2.4, we're looking at rates of change in tangent lines. One of the things that you want to know right now is an average rate of change is nothing more than the slope of a line between 2 points. And all you're going to do is literally find the slope of the line, which is something that we've done from Algebra 1. Another thing, tangent lines. If you remember, a tangent line is a line, we first learned about them in a circle. Hold on, let me draw a little better circle anyway. And a tangent line was a line that intersected the circle, a line, so it goes on forever, that intersected a circle at one point, which means it had to graze off the side of it. Because if we had a line that went in like this, it would hit here, but remember the arrow means it's going to keep going and go on through. Now, here's the thing. This is a secant line. This is a tangent line. So we're actually looking at both of those when we're talking about the average rates of change in a tangent line. The average rate of change is found by using the slope of the secant line because we've got 2 points. So it's kind of almost a flashback to when we were talking about tangent and secants of circles, except we're talking about tangents and secants of functions. All right, so let's look at this first question here. It says find the average rate of change of the function over the given intervals. Now I'm not going to work both of those out, but I'll work one. Now remember, slope is average rate of change, AROC, and slope, of course, is also y2 minus y1 over x2 minus x1. Well, you're also going to see it written as f of b minus f of a over b minus a, where b and a are the x values and f of b and f of a are the y values. And that's what we're going to do here. So this is going to be my a, that's going to be my b, and of course there's my function. So I'm going to find f of 7 minus f of 5 all over 7 minus 5. And I'm probably going to run out of room here, but I'm going to go ahead and do it anyway. So we've got 2x cubed plus 2. We've got 2 times 7 cubed plus 2 minus, and you want to put brackets around the second part over here, because remember you're subtracting everything, and you're going to get 2 times 5 cubed plus 2. And that's all over 7 minus 5. So 7 cubed is 343 times 2 plus 2. That's going to give me 688. And then if I do this part, I've got 5 cubed, which is going to be 125 times 2 plus 2, which gives me 252. And I'm dividing by 7 minus 5, which is going to be 2. So 688 minus 252 is 436 divided by 2, which is going to give us 218. All right, so that's all you're doing. Now, remember, I showed every single step here, including some, so you don't have to show all this, but you've got to show enough that we know that you can tell where your work comes from. All right, and you would do the exact same thing with the second one. All right, same thing here between x equals 2 and x equals 12. They're just giving it that just a little different. Same thing here. You just got to know your trig function. Sine of pi over 3 minus sine of pi over 6. And notice the way that these are written. Guys, you're expected to do this without a calculator. You have to know your trig functions. At least the sine and the cosine anyway. All right, the figure to the right shows a distance time graph for a muscle car accelerating from a standstill. Use the information in the figure to answer parts A and B. All right, so the slopes of the sequence PQ1, PQ2, PQ3. So you're just going from the end point down to Q1, Q2, Q3, and Q4. Those are just simply, you got the values over here, so there are your points. It's not like it's something very complicated. And let's go ahead and look at part B. Okay, it won't let me look at part B. Yeah, I'm not working all those out. All right, at the indicated point, find A, the slope of the curve, an equation of the tangent, and the equation of the normal. Then draw the graph of the curve, tangent line, and normal line in the same square viewing window. All right, so now the slope of the curve is not the same thing as the average rate of change. Okay, when we're talking about a curve, the average rate of change is over some interval from A to B in this case. When we talk about the slope of the curve, we're actually talking about what the slope is at a single point. The slope of the curve is the slope of the tangent line at that value of x. That's found a little bit differently. Now what we're going to end up doing is we're going to end up finding out what the slope of the curve is at x equals -1. Then we're going to write the equation of the tangent line and the equation of the normal. All right, so the way we're going to do this is we're going to end up taking the slope of the curve, and we're going to find it by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, guys, just a little bit of background here. This is called the difference quotient, and this actually is nothing more than another way of writing y2 minus y1 over x2 minus x1. Just to show you that, this is y2, this is y1, and on the bottom we would have x plus h minus x, and the x's cancel out. So to kind of give you a graphical representation, what we're doing is we're looking at this. If we've got a point right here, x, that we want to find the slope of the curve at, what we're going to do is we're going to go over some value h, and we're going to put another point. And so that means that this value is x plus h, and then here we're just finding the y values at those two x values. But what the limit's going to do, if we're letting h go to 0, what are we doing to these 2 points? Well, if h is the difference between them, the distance between them, that means we're bringing those 2 points closer and closer and closer and closer together without actually being the exact same point. But they're going to get infinitely close together, and that's going to give us the slope of the curve. All right, so let's do this. Let's work this thing out. And we're going to do x squared minus 4x. So I'm going to move over here. I'm going to change colors here. So I'm going to take the limit as h approaches 0. And then I'm going to put x plus h, this whole thing right here, everywhere I got an x. So I'm going to have x plus h squared minus 4 times x plus h. That's my function. And then I'm going to subtract. That's my function with x plus h in it. Now I'm going to go back and plug in just x. and that just means I'm going to get x squared minus 4x. And then I'm going to put all that over that h on the bottom. So right here, just to kind of give you this part right here, is f of x plus h, and this part over here is f of x. Make sure you put those parentheses around it, because you remember you're subtracting both these parts. So that means you're actually going to end up adding the 4x. You're going to find that a lot of this stuff, I don't know why I did that. Let me go back. You're going to find that a lot of this stuff is just nothing more than algebra. So algebra is very, 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 very important. All right, so then of course we're going to have to square this, and we're going to have to distribute this, and then we're going to have to simplify out. We've got the limit as h approaches 0. X plus h squared is going to give me x squared plus 2xh plus h squared. Distributing the 4, I'm going to get minus 4x minus 4h. Then I'm going to go ahead and distribute this minus all the way through, so I'm going to get minus x squared plus 4x. And that's still all over h. All right, now right here, this is where you need to make sure that you know what to expect. That way you can check your work as you're going along. So now we're going to simplify this. We're going to combine like terms and all that jazz. So we've got x squared here, and we've got a minus x squared here. So those are going to cancel out. We have a minus 4x here and a plus 4x here. Those are going to cancel out. This is a check area right here. This is a thing that you need to think about and keep in mind every time you do one of these. At this point right here, once you simplify that top, you should not have any terms that do not have an h in them. If you do, you've done something wrong. You've multiplied something wrong, you've distributed something wrong. Some error has been made. If you have any terms on this top, once it's simplified, that do not have an h in them, and you're going to see why in just a second. So now, once we've got that, we can move everything over here that's still left. We're going to get 2xh plus h squared minus 4h. You got that term, and that term, so that's everything. And notice every one of these terms has an h in it. Now, the reason why that it's very, very important for that to happen is that if you have an h in every term up here, you have an h that you can factor out. So you're going to have the limit as h approaches 0 of h times 2x. Take an h out of that, we're going to get plus h. Take an h out of that, we're going to get minus 4 over h. So now, hopefully you can see this with algebra, those h's are going to cancel. So we're going to be left with the limit as h approaches 0 of 2x plus h minus 4. Now, if h goes to 0, that means this term right here is going to go away, and you're just going to be left with 2x minus 4. Now, what we've just found here, this is a new function. It just so happens that we've actually just done calculus. This is actually a derivative. We found the derivative of the thing that we started off with. And what the derivative tells us is the slope of the curve at a given point. So this point right here, this thing right here tells us the slope at any value of x that we want to plug in. Now we need it at x equals -1. So if we've got 2x minus 4 is the slope everywhere, then we can evaluate that at -1. So we've got 2 times -1 gives us -2, minus 4 gives us -6. So that should be our answer. Well done. All right, so now an equation for the tangent line that comes specifically from y minus y1 equals m times x minus x1. And that's nothing more than the point-slope form. So we've got to have a point and we've got to have the slope. Well, we already have the slope, it's -6. So that will be going in right here. We already know what our x value is, it's -1, so it's going to be going in right here. We don't know our y value though, but what we can do is we can take our x value, plug it in right there, and that's going to give us our y value at that point. Because remember, all that equation right there is the relationship of how x relates to y. So the y we're looking for is going to be -1 squared minus 4 times -1. So if we do that, we've got -1 squared, which is going to be 1, minus 4 times -1, which is going to give us a +4. So that means we're going to have a value of 5. So 5 goes right there. We've got y minus 5 equals -6 times x minus x1, or -1. So when we simplify, we have y minus 1, or 5, I don't know where the 1's coming from, 5 equals -6 times x plus 1. So this is x plus 1 right here. When we distribute that, we're going to have -6 times x gives us -6x. -6 times +1 gives us -6. And we're going to add 5 to both sides, plus 5 plus 5. Y is equal to -6x minus 1. So that should be our tangent line. -6x minus 1. Good job. All right, now a normal line, if we have a line here, the normal line is going to be perpendicular to the other line. So if this is my tangent, a normal line is going to go through the exact same point, but it's going to be perpendicular to the tangent line. Now, if you remember, the only thing we've got to change with our tangent or perpendicular lines is our slope. So if we have a slope of -6 for one line, the slope of the line tangent to that is going to be the negative reciprocal. So we're going to flip this thing over, think of it as -6 over 1. We're going to flip it over and get 1/6 and change the sign. Where it was negative here, it's now going to be positive. So that has to go in all the way back to y minus y1 equals m times x minus x1. So when we plug everything in, we're going to get y minus 5 is equal to 1/6 x plus 1. All right, so simplifying here, we got y minus 5 equals 1/6 x plus 1/6. And then when we add 5 to both sides, plus 5, we're going to get y is equal to 1/6 x plus 5 expressed in 6 is 30 over 6. So that's going to give us 31/6. Alright, so fraction 1/6 x plus, wait a minute, is it a plus or a minus? Hang on. Let me go back and look at it again. Alright. Yeah, plus 31/6. Nice work. So that's all there is to it. And the drawing of the curve and everything, I'm not going to do that because you're just going to end up picking one anyway. Just understand that, get your tangent point, the graph and everything, and figure out which one it is. All right, so same thing here, but I'm going to kind of help you out a little bit on this one. When you do your f of x plus h, you're going to end up with 1 over x plus h minus 4 minus 1 over x minus 4. So that looks really, really ugly. It's not that bad. What you need to do is you need to multiply and get a common denominator so you can combine them together. So with this one, I'm going to have to multiply by x minus 4 over x minus 4. This one over here, I'm going to multiply by x plus h minus 4 over x plus h minus 4. All right, so what's going to happen there is now I'm going to have x minus 4. I'm just doing the top right now because now I've got a common denominator so I can put these all together. So I've got x minus 4 times 1. That gives me my x minus 4. And then I've got minus x plus h minus 4 times 1, which is x plus h minus 4. And on the bottom, you got x minus 4 times x plus h minus 4. Guys, don't multiply this bottom out. Don't multiply the bottom out. It'll make sense in just a little while why you're not going to do that. All right, so we've got that, and when we subtract these over here, we're going to end up with minus x minus h plus 4. And what do you notice about the x's and the 4's? They're going to cancel out. So once again, the same way I told you before, if you end up on top, the very, very top, with a term that does not have an h in it, you've done something wrong. So now all we've got is minus h on top. So we have minus h over x minus 4 times x plus h minus 4. Now, guys, don't forget, you still have this h on the bottom all the way across here. I was just dealing with the top. So now, right there, we can do a little keep, change, flip action. So you get negative h over x minus 4 times x plus 4 h minus 4 times this thing. Dividing by h is the same thing as multiplying by its reciprocal, and we're going to cancel these out. Don't forget your negative though. So we get the negative 1 over x minus 4 times x plus h minus 4. Now remember, along this whole thing, I didn't write this out every time, but remember, what are you doing? At the very end, you're taking, all this went along with it as you go through, but the limit is going to be taken at the very end. And where's the only place you're going to plug the 0 in? Boom, right there. So what do you end up with? Negative 1 over x minus 4 times x minus 4. Or negative 1 over x minus 4 quantity squared. So there would be your slope of the curve. All right, I'm not going to do all the rest of that problem for you because, well, the rest of it's just algebra anyway. But I wanted you to see how to do that. Now, for this one, two things have to happen. You've got to check and see if it's continuous at 0, because that's the place where we're checking. And if it's not continuous at 0, then the slope's going to be undefined. If it is continuous at 0, you have to check and see, does the slope from this side and the slope from that side equal the same thing as you get closer and closer to 0. If it doesn't, then you can move on. So right now we're going to plug in 0, and we're going to get 5 minus 0 minus 0. That's going to be the less than 0 part. The greater than 0 part, we're going to plug in 0, and we're going to get negative 2 times 0 plus 5 gives me 5. So on both parts of this, we're approaching 5. Now, here's a little trick. Remember, all the slope of the tangent is the slope of this equation at a given point. Well, if you recognize this right here, that is a line. And what do we know about the slope of a line? It's always the same. So if you think about y equals negative 2x plus 5, well, the slope of the line is negative 2. So here the slope is negative 2. So now the only thing you got to worry about is this top up here. And you actually have to go through the whole process of finding the slope, the way we've done on the last couple of problems, and then plugging in 0 to see if, as we get closer and closer to 0, that slope is negative 2. If the slope is not negative 2 at 0, then we know that this thing is not going to have a tangent at the indicated point. All right, now, I didn't work it out. I want you guys to work it out, but what you're going to end up finding is that this value right here, the slope ends up being negative 5 at x equals 0, and these are not equal. So if these two don't approach the same value, they have to have the same slope. Otherwise, we end up with what's a point. So we've got negative 2, and then we've got negative 5. That's not a very good drawing there. We've got negative 5. That's a point or a corner, and a corner is not going to have, it has to be nice and smooth. That's not a smooth transition. So that's one of the reasons why you're not going to have a slope. So the slope is going to be undefined here. Alright, that one pretty straightforward. I'll let you guys work that one. Okay, functions are done the exact same way. Instantaneous rate of change is just another way of saying the slope of the tangent line. So you're doing the exact same thing. Now if you find the instantaneous rate of change of the position, guess what? That's velocity. So you're actually finding the velocity of this particle as you're going through. But you're going to do this the exact same way. You just have a t instead of an x. All right, same thing here. It's speed, 10 seconds. So you're going to find the instantaneous rate of change of this using the difference quotient and the limit. And then you're going to plug in 10 to find out what the speed is. Same thing. Now let you guys figure that one out. Same thing here with this one. You guys can kind of think through that and know and figure it out. All right, if you cannot figure this one out, me and you need to talk. Yeah, definitely need to talk. All right, so this one's going to be similar, but actually simpler than that fraction one we had before. But you can do it, and then you're just going to take that one step further to find, given the x, you got to find the y, and then you can plug in and find out what the equation of the tangent line is. So that's it. 2-4 is not actually really that hard a section once you kind of get it under your feet. All right, if you've got questions, email me, let me know. Talk to you guys later.